So today is the fifth class of chemical bonding. So in the previous class, I have discussed about the polar bond and covalent ionic bond. So now in this lectures, I will discuss the Vesper theory. So what is the full form of the Vesper theory? The full form of the Vesper theory is the valence shell electron pair repulsion. The valence shell electron pair repulsion. Okay, so in this theory, if you see clearly, the full form of the Vesper theory is the valence shell electrons and this is the repulsion. Okay, so whatever I will discuss here, this is about the valence shell electron pairs and they are the repulsion. Okay, so in the first class we know about the Lewis dot structure, but from this Lewis dot structure, okay, so this structure, from this Lewis dot structure concept, we cannot define any stability of or the shape of the molecule. This is shape of the molecule we cannot define by this Lewis dot structure. Okay, so to know the shape of the molecules, we will know about the Vesper theory. So Vesper theory means the valence shell electron pair repulsion. So to know about the shape and the structure of a molecule, first 1940, if I know about the 1940, scientist Sadwicks and scientist Powell, they discover a theory. This is called the valence bond Vesper theory. So this Vesper theory, basically they have discussed about the repulsion of valence shell electrons. Okay, so whatever is there, that is basically repulsion or the repulsion between the valence shell electrons. So now why this term is coming? This is the repulsion. We know that the electrons, when we are talking about this electrons is the negatively charged. Okay, it has the minus negative charge. So we know when it is the repulsion, when we are telling about the repulsion of the valence shell electrons, that means the electron repulsion. So that means the negative charge and the negative charge is there. So there will be not attraction, there will be the repulsion. Okay, so that's why we are talking about here the repulsion of valence shell electrons. So now there is the some postulate of the Vesper theory. First postulate is that the shape of a molecule depends upon the number of the valence shell electrons. This is the bonded or the non-bonded around the central atom. So whatever metal complex will be, whatever molecules will be there, okay, you have to define first this central atom. This is the central atom. So about this central atom, the shape of or the structure of the molecules will be determined. So first is there the number of valence shell electron pair that would be the bonded or the non-bonded. Okay, so based upon that number of valence shell electron pair, the shape of molecule will be determined. That is the thing. This is the first postulate. Second postulate is that pair of the electron in the valence shell repel one another since there the electrons clouds are negatively charged. So if you see the valence shell electron shell, so there is the suppose there is the 3 cell, there is the one electron, there is the one electron. So among this 2 electrons there is a repulsion. Okay, so due to this repulsion, repulsion between two negative charged charges electrons. Okay, so whatever electron clouds will be negatively charged. So electron clouds are negatively charged. Third postulate is that the pair of the electrons tends to occupy the such position in phase that minimize the repulsion and the maximum distance. So suppose there is an electron cloud, there is an electron cloud. Okay, so among this between this electron there will be the repulsion. So due to this repulsion, this electron always wants to go far away from to each other, and they will take a distance where the minimum repulsion and the maximum distance. So due to this repulsion, always the pair of the electrons, so there is a pair of the electrons, there is a pair of the electrons. So this pair of the electrons, there is a repulsion between these two pair of the electrons. So due to this repulsion, there will be some distance between the two pair of the electrons will be created. That's why this pair of the electron tends to occupy such position in phase minimize repulsion. So in this position, minimize repulsion and maximum distance. But in that situation, if you see maximum repulsion and minimum distance, so two situations are the different. In that situation, between these two electrons pair, distance is very less. That's why distance is the very less. That's why there the repulsion will be very high. So due to this repulsion between these two electrons pair, the distance of this two electrons pair will be the high. So that's why it is a maximum distance. So when the distance is the high, then the repulsion between the two electrons pair will be minimum. Another postulate is that the valence shell is taken as a sphere with the electron pair localizing on the spherical surface at the maximum distance from the another. So whatever we are talking about this valence shell, so always this valence shell, valence shell electron pair will act as a sphere. This is the taken as a sphere. This is sphere, and there is a sphere. Okay. So to create the minimum repulsion, the distance will be high. So always they will be present as maximum distance. Another point is that a multiple bond is treated as if a single electron pair. Suppose there is a single bond, there is a single electron pair is there. Okay. So when it is a single electron bond pair, it is a multiple bond. It is a multiple bond. But when there is a double bond, there is a triple bond is there. Okay, suppose there is a double bond, there is a triple bond is there. So when it is double bond, that means there is the 2 electron pair is there. There is a 3 electron pair is there. Okay, so maximum when the more than the 1 electron pair, then we can say it is as a single super pair. So it is a single super pair. So these are the postulate. There is a some points is there. Okay, so these are the postulate. So among this, depends upon this postulate, this specific postulates, we will define the structure, what will be the structure of the molecules, and what will be the distorted structure or the full structure, how it will be the determined among these bonded electrons and the non-bonded electrons. If I give this some example, it will be the very better to understand. So before that, there is some point. The repulsive interaction of electrons pair decrease in order. So if you know a molecules always they are present bonded electrons pair, non-bonded electrons pair. That means actually the lone pair. So it is a BP and it is a LP. So if you see, suppose this is a molecules, let us consider. So these are the bonded electron pairs. So this is a bonded electrons pair and these are the lone pair. So these are the lone pair and these are the bonded electron pair. You see carefully, this lone pair as a free. This lone pair, they are the free. These are the free. Okay. But if you see these bonded electrons pair are involved, these are the involved to make a bond. To make a bond. Similarly here also. So these bonded electrons pair are not free. They are the not free. Okay. So bonded electron pair is not free, but lone pair is free. So due to this freeness of the lone pair repulsion, lone pair repulsion will be more, because these are the non-bonded, these are the lone pair, they are not involved in the another works. Okay, so they are the free. That's why a lone pair repulsion is the maximum. Then lone pair bond pair repulsion will be that reason. Then at the end, bond pair repulsion. So if you see the order of the repulsive interaction of the bond pair and the lone pair, the bond pair repulsion will be less, then bond pair lone pair repulsion will be in medium position, but lone pair repulsion will be very high. So this is the case. Okay. So this is the important point. This is the important points. Why this lone pair repulsion is the very high than the bond pair repulsion. Okay. So now, according to the number of electrons pair, so in this electrons pair there will be involved bond pair also and the lone pair also. So number of the lone pairs, according to the number of the lone pairs, we will define the shape of molecule. How? Suppose total number of this is the total. This is the total number of the bond pair plus lone pair. Okay. Suppose there are 2. Total electrons pair is the 2. Okay, number of the electron pair is the 2. When the number of the electron pair is the 2, then the structure will be linear. When it is a 3, the structure will be trigonal linear. When the total number of the lone pair is 4, then it is the tetrahedral. Is the 5 is a trigonal bipyramidal structure. Then the 6, it will be octahedral. And also it is the 7, it will be the structure will be bipyramidal planar structure. How it is that? And also it is a tetrahedral, another structure will be the square planar. Okay, so let us just again I will draw all the structure. When the lone pair, this is the number of electron pair, and this is the shape, and this is the structure. Not the structure, it will also the shape, the geometry, shape or the geometry. Okay, so first is the two is a linear. So linear means it will be like that. The angle will be 180 degree. Like for example, barium chloride, HgCl2. These are all the linear structures. CO2 structure, oxygen, C double bond 2. So these are the linear. So these are the linear. The angle between these two bonds will be 180 degree. Then if you see the 3, it is a trigonal planar. So trigonal planar, when it is a trigonal planar, the angle will be 120 degree. So the structure will be like that. This angle will be 120 degree. Okay, let us consider BF3. Okay, so the structure is like that. It is a trigonal planar structure. Okay, a trigonal planar structure, BF3. Now, if you see, it is a 4. So this is the tetrahedral. When it is a tetrahedral, then angle will be 109.5 degree. Okay, so it will be structure like that. Okay, it will structure like that. So, like example, NH3 ammonia, NH3 ammonia. This lone pair will be that position, hydrogen will be that position, and that will be that position. Suppose the NF3, NF3. So nitrogen will be the position. This is the fluorine, and this will be the fluorine, and this will be the fluorine. It will be like that actually, above the plane and then below the plane. Now another also, suppose the square planar would be happened, square planar, then the angle between is the 90 degree. Is the square planar structure. This angle will be 90 degree. For example, if you see any metal complex, or if you see nickel, CnR4 like that, nickel will be there, the Cn molecules is there, this is the Cn, and this is also the Cn. So like that is the structure. The 5. So this is the bipyramidal, trigonal bipyramidal, It is called the TBP. The structure will be like that. Okay, so this is the T structure. This is a TBP structure. Like if you see BCl5, phosphorus will be there, cell in this position, cell in this position, cell in the position. There is another cell that. Okay, this is the TBP structure, and this is the 6 is the octahedral. Octahedral structure will be like that. Like example, the SF6, sulfur will be there, fluorine. You guys just remember, when the number of the electrons is the 4, then structure will be the tetrahedral or the square planar. When the number will be the 5, it will be the trigonal pyramidal structure. When number will be the 6, it is the octahedral structure. It is the 3, then trigonal planar structure. It is the 2, then it is the linear structure. And also the remember the bond angle. So here is the bond angle is the 2 types. Okay, so this angle will be 180 degree, this angle will be 90 degree, and if you see this angle will be 120 degree. So there will be the various type of the bond angle is there. Okay, 120, 90, 180 degree. Again here also, if you see, this is the 90 degree, this is the 180 degree. Okay, so here also 90 degree and 180 degree bond angle is present. So various type of the bond angle is present in the molecules. And also if you have to know about the structure, you have to draw properly, you have to draw the structure, and according to the, you have to remember the how many lone pair is there, and corresponding the number of the lone pair, what would be the safe. When the number of the lone pair is the 2, when number of the lone pair is the 2, then it is the linear structure. When it is the 3, then the trigonal planar structure. 4, then the tetrahedral or the square planar. Then 5, it is a trigonal bipyramidal, this is a TBP structure. And when it is the 6, then it is the octahedral structure. Okay, so these are the general thing for the Hilsberg theory, how you will know the shape of the molecule according to the total number of electron pair, not the total number of electron. It is always you have to know the total number of electron pair. Okay, it is a pair, not electrons. Okay, so now suppose I am giving an example. Suppose the NH3. Okay, so in this molecule, suppose the NH3, what will be the structure, what will be the shape or the geometry of this molecule. Okay, so first you have to know the number of electron pair. Okay, first you have to know the number of the electron pairs. So again you go to the Lewis dot structure. So this is the lone pair. Okay, here will be the 3 bond NH, there's the hydrogen, this is the hydrogen. Okay, so if you clearly see, this is the bonded electron pair, this is the bonded electron pair, this is a bonded electron pair. So total number of the bonded electron pair, so bonded electrons pair equal to 3, but lone pair equal to the 1. So total 4. So when it is a 4, it is giving 2 structure. One is the tetrahedral, it will be the tetrahedral structure, and another is the square planar. But here the square planar is not possible because of this lone pair, and another is the tetrahedral structure. So it will have the tetrahedral structure. So when it is a tetrahedral structure, then angle will be 120 degree. So in this way, you have to cast the total number of the bonded electron pair. Then you have to go the shape and the geometry. Let us consider the SF6. We know that SF6, that means with this sulfur there is the 4 fluorine is bonded. Okay, so bonded electrons pair will be 6. There is another lone pair is there? No. Okay, now how you know that? How you know that there is the no lone pair? Because if you see the sulfur electronic configuration, the valence electronic configuration, okay, so the number of the electrons, the valence electrons will be the 6. Okay, so 6 lone pair is there, 6 electron is there, and 6 electron from the sulfur, so they will form the 6 bonded electron pair. Again, I am just draw the valence shell. So this is the 3s, this is the 3p, and this is the 3d. This is a 3d. So when it is a sulfur, so oxygen series is there. So valence electron equal to the 6. So 1, 2, 3, 4, 5, and the 6. Okay, but again, due to the presence of the fluorine, this bonded electrons will be, this pair of the electrons will be the non-pair. So this will be the that things. So again, there will be the fluorine. There is a fluorine is coming, fluorine is coming, fluorine is coming, fluorine is coming. So total 1, 2, 3, 4, 5, 6. So 6 bonded electrons pair. 6 bonded electrons pair. So when it is a 6 bonded electrons pair in the valence cell, so 6 means it will give the octahedral structure. It will give the octahedral structure. If you see in the valence cell, there is no lone pair. Okay, so there is a no lone pair, only presents the bonded electrons pair. That's why lone pair equal to 0 and bonded electron pair equal to 6. So 6 means the structure will be the octahedral. If you consider the PCl5, you see the PCl5. Okay, so if you see the PCl5, so from that 5Cl, the bonded electrons pair will be the 5 and lone pair will be the 0. So total bonded electron pair is the 5. So when it is the 5, then the structure will be the trigonal bipyramidal structure. Trigonal bipyramidal structure. Okay, trigonal bipyramidal structure according to the total number of the electrons. So according to the total number of the electrons pair, you have to know about the geometry according to that. Now, the second point is that molecules type. It is molecules type. It is nothing is that whatever I am telling, it is a similar like that. Okay, again I am telling you. Suppose this is a molecule A, B to E. E for lone pair. Okay, E for lone pair. A is the central atom, and E for the lone pair. Okay, so when it is the AB to E, that means the bonded electron pair equal to 2. This is the bonded electrons pair, and this is the lone pair. The lone pair equal to 1. So total is 3. So this is the total. So total is the 3. When it is the 3, then the structure will be trigonal bipyramidal structure. So its structure is like that. Okay. So it is a trigonal this is the trigonal planar structure. This is a trigonal planar structure. Trigonal planar structure. But if you see the shape bent, for example, SO2 O3. Another thing, this is a AB3E. AB3E means the bonded electrons pair will be the 3, is a 3, and lone pair will be the 1. So total is the 4. So 4 means the structure will be A will be there. There is the lone pair. There is the B. There is the another B, and there is the another B. So the structure will be the tetrahedron. Okay, the structure is a tetrahedron. Like example, and the shape will be trigonal pyramidal. Trigonal pyramidal or the tetrahedral, the same. Trigonal pyramidal or the tetrahedral is the same. Like the example is the NH3. Another, if you see the example A B2T ET, that means the bonded electron pair equal to lone pair equal to 2, total number of electron equal to the 4. So this is the bonded electron pair, this is the lone pair electron pair, this is the total. The total equal to 4. So when it is a 4, then we know that again the structure will be A, lone pair is there, that is lone pair, another is the B, another is the B. Okay, so it has the tetrahedral structure. But if you see only the 2 electrons, so it is a bent structure, bent. For example, if you see the water, H2O, oxygen will be there in this position. So this is the electron repulsion. We know that lone pair repulsion is the greater than lone pair electron is the greater than to lone pair to bond pair. Okay, again I will come to that point. Okay, so another thing, if you see A before E, so bonded electron pair equal to 4, lone pair equal to 1, so total equal to 5. Okay, so the structure will be it will be like that. Lone pair. So the structure is square pyramidal, or if you eliminate the lone pair, then it is a square planar, or if you another also the structure will be uh, so the structure will be, this is a trigonal bipyramidal structure. This is a trigonal bipyramidal structure, but it is a seesaw structure. When this lone pair will be in plane, then it is a seesaw structure. But another, if you see this example, this is a very important thing. When this is the AB3 T2, so 100 equal to 3, lone pair equal to 2, total equal to 5. So again the structure will be, so this is the 3 and this lone pair will be the 2, so lone pair will be the 2, and this is the B and this is the B. If you the structure equal to the T shape, previous slide, if you see this lone pair is present is here, there is a one lone pair, so it is a seesaw structure, and here there is a two lone pair is present, there is one lone pair, there is one lone pair, and the structure is coming the T shape, so it is a T shape structure. And another always the possible, that one is a square pyramidal structure. Sorry, that is the square pyramidal structure. So if you see, when the total number of electrons equal to the 5, then there is the three possibility. One is square pyramidal structure, another is the seesaw structure, another is the T-shape structure. Okay, so that actually varies of number of bond pair or the number of the lone. Another thing, if you see AB4 E2, that means the 4 bond pair, 2 lone pair, so total is the 6. So the structure will be, there is a boron, there is the boron, there is the boron, there is the boron. So lone pair will be like in position. So it is shape is the octahedral, but the shape is the square planar. If you eliminate this lone pair, only the consider the molecule, then the structure will be the square planar. Like HCF4 is xenon, is the fluorine, the fluorine is a fluorine. There is the lone pair. So this is a structure and this is a shape. So there is some exception I will discuss here. For I am considering this first is water. Okay, for this water molecules H2. So from that water molecules we know that it always has the two lone pair. So bonded electrons pair equal to 2 and lone pair equal to 2. So total equal to the 4. The structure will be the tetrahedral. So when it is a tetrahedral, so the geometry will be like that. Okay, the geometry will be like that. But due to the lone pair repulsion, when it is a repulsion to each other, then and also there is the lone pair bond pair repulsion, and bond pair repulsion is there. Okay, so due to that the structure will be bent. Okay, so lone pair repulsion is there, the shape should be tetrahedral, but there are all bond pairs and the two lone pairs are the present, so that the shape is the distorted tetrahedral structure. And the reason is the lone pair repulsion is the more than the lone pair bond pair repulsion, which is the more than the bond pair repulsion. That's why if you see this repulsion, so there is a bond pair also repulsion is there, lone pair bond pair also repulsion is there, lone pair repulsion is there. Okay, so due to that presence of the three types of the repulsion, the structure is the distorted tetrahedral. And we know that for the tetrahedral structure the angle equal to 109.5 degree, but due to that repulsion the angle will be 104.5 degree. Okay, so the repulsion angle will be the less, angle will be the less, that repulsion is present, that repulsion is present. So when, that's why this angle is the less, 109 to the 104.5 degree. Another thing, if you see for that NH3 case also, for that NH3 case, if you see the structure NH3, okay, so for that case what is happening here, we know that this is a tetrahedral geometry, angle should be 10.5 degree, but its angle is 107 degree. This angle is quite less. Why? Because you see there is the bonded electron pair is there, bonded electron pair repulsion is there, but there is a bonded and a lone pair. So there is the two repulsion is present. One is the lone pair bonded electron pair and the bonded electron pair. And we know that bonded and lone pair interaction is the greater than the bonded. So that's why these interactions will be the high than that repulsion. That's why this angle will be quite less than 109.5 degree. So that's why its angle is equal to 107 degree. So due to that repulsion of bonded electron pair and the lone pair. Another example, if you see SO2 molecule. So from that SO2 molecule, just first consider the structure. So here oxygen, with this oxygen sulfur will be the two bonded electrons, so two bonded electrons, but sulfur will be have one lone pair. Okay, so sulfur will be have the one lone pair, so equal to the 3. So when it is a 3, then the structure will be trigonal. So this is sulfur lone pair, that will be the structure, but it will have the bent structure. So total bonded electrons pair equal to the 4, that is the 1, so equal to the 5. So theoretically the shape should have been trigonal planar, but actually it is a found to be a bent or the V-shaped structure. So the reason being the lone pair and bonded pair repulsion is the much more as compared to the bonded. What is happening here? If you see, there is a lone pair also is there, there is a lone pair is there, there is a lone pair is there. Okay, so whatever repulsion present is here, but this repulsion is the greater than this. So there is a lone pair bond pair repulsion, there is a bond pair repulsion, and we know that lone pair bond pair repulsion is greater than to the bond pair repulsion. That's why this structure is the V-shaped structure. It should be the trigonal planar structure, but it is a V-shaped structure or the bent structure. We can say it is a bent shape, or we can say it is a V-shape. That's why it is a so it is a trigonal planar. So the structure will be the angle should be 120 degree, but due to that repulsion the angle is 119.5 degree. Okay, so here I have closed the class. Whatever example is remaining, you guys can continue. So in this Vespa theory, just based upon the number of the total electron pair, which is the bonded electron pair and which is the lone pair, this is the non-bonded electron pair. Here we have determined the shape and the molecules. What will be the shape of the molecules? When it is the 2, then it is the linear.
When it is a 3, it is a trigonal. And when it is a 4, it is a tetrahedron. It is a 5, this is the bipentagonal structure. When it is a 6, this is the octahedron. So based upon that, total number of the bonded electron and the non-bonded electrons, we can determine the shape of the molecules. So here I will close the class. In the next class, I will discuss about some example based upon the whisper theory. Then I will continue the PPT.